All right. Good evening, everyone.
Evening.
All right. Good evening, everyone. Welcome to Lightning Talks, NAIJA-Java user group. So today happens to be a Lightning Talks for this week. So without wasting much time, apology for keeping you waiting and apology for not turning on my camera. Where I am, we are out of power and it's kind of dark. So please bear with me. And apology for the time adjusted earlier. So without wasting much time, we want to call on our one and only. The He's no other person than Mr. Bright. He's no other person than Mr. Bright. Please, can we just react with our favorite emoji as we welcome him to take the floor? Thank you.
Hi, good evening, everyone. Can you hear me? Hello?
Very well, very well. You are coming out clearly.
Okay. Thank you. Sorry, I was battling with the network earlier. So I'll proceed to share my screen so that we can quickly get started. Yeah, so please, if at any point you stop hearing me, just call me back because my network is not too solid. Yeah, so can you see my screen? Uh,
Very well.
okay,
Not yet.
thanks very much. Yeah, so can you see this? Can you see the page I'm sharing?
Clear from my
You're
end.
presenting, yeah, but your DP that we are seeing.
Uh, who else is
Clear
not
from
seeing
my
it?
I can see your screen. I can see your screen.
Okay,
end. Yeah.
so I think you may need to rejoin again. Yeah, so I'll quickly
Okay, yeah,
get
we can
started.
see.
Okay, thank you. So I want to use 30 minutes for this, so I can use the rest time for questions. Yeah, so over the next 30 minutes, I'll be speaking on SQL optimization strategies. These are just little acts, little actions that make the big difference, right? So we'll be speaking on. I'll be speaking on. What is SQL? What problem is SQL solving? Why SQL optimization matters? How to write efficient queries, indexing strategies, and avoiding common performance killers. Yeah, so this is actually like a large, will I say, a broad topic. So I'll just be picking them like very fast so I can beat time, right? Yeah, so I may not like go deep into it. Yeah. All right. So over time, working as a back engineer, I've, come to realize that data handling, manipulation, is a single factor that separates a great system from a failing one. Poor queries may go unnoticed with few records, few user records, but once the record grows into millions, they can wreck an entire system, like for real, right? So in this lecture, we'll explore practical ways to write better optimized queries. Can you all hear me?
Very well, very
Yes,
well.
we
You are
can.
coming out clearly.
Okay. All right. Thank you. So, to set, a background for this, we'll first be looking into what is SQL. So I believe we all have a basic understanding of SQL, but to ensure that everyone is carried along, let's briefly look into what SQL is all about. SQL, it stands for Structured Query Language, and it was developed by IBM in the 1970s. And it is used for storing, manipulating, retrieving data in relational databases. This in relational databases, right? It is declarative in nature, meaning that you just give a command on what you want, and the database engine will work out its way on how to give it to you. So you don't tell the database how to get it for you. Just give a command and it will, give you what you want. Yeah, next slide. What problem does SQL solve? Why do we even need SQL in the first place? Prior to SQL, data was stored in text files, commonly known as flat files, right? For you to access information, you need to like write custom code to pass this file and retrieve information. Yeah, for those that have worked with, Google, what is it called? Google, what is it called? Table, right? In your Java, you see that you are writing like custom code to like run through all those tables, and get what you want. That is how tedious it was prior to SQL. So it came with a standardized way to interact with data. It abstracted data processing. So you only need to tell the DB what you want and it will get it for you. That's the declarative way. So, and also it makes handling joins very, very easy, right? So with this, we have set like the background on what SQL is in case we have anybody with us that may not really have much knowledge on SQL. So with this, we have set the background, right? Great. So I believe you guys can hear me, right?
Very well, very well. You are coming out clearly.
Great, thanks. All right, so since SQL, solves all these things for us, the declarative way and, making joins very, very easy. So why then do we need to optimize? Like, why does it matter? This optimization, why does it matter? So, if SQL is done wrongly, it provides little to no benefit to anyone, right? So optimized queries ensures that customer satisfaction, when your customers are happy, when they can easily access your web-based or mobile app, they are happy, and that translates to money. They can happily pay for their subscriptions and the rest. Optimized query ensures reduced CPU memory usage, thereby saving costs on cloud provisioning. You don't have to fetch so much records, right? So it ensures system stability, as one bad query can impact the entire system, right? So while you may not really see this effect on little tables, it gets really, really worse when you have very, very large tables. For those that are into large data processing, you're handling over, billions of records, right? You can see that a little harmless query, which we'll see, with time, can actually bring down everything, right? So this is why optimization is of utmost importance, right? So we have seen the background for SQL. We have seen why optimization is important, even if SQL solves the problem for you, giving you the declarative approach and everything, but you still need to optimize it, right? All right, so let's slowly go into the practical section of this course so that we don't end the whole section just talking. All right, so for this section, it will be a lab. So we'll quickly create a database on the Beaver. You can use pgadmin, but I believe we have been using pgadmin in our place of work, so it won't hurt, to try something new. The Beaver is like, there's no new, to try out a different DB, right? So we use it to create a table called scoreboard, and we'll create the following columns inside it: ID, mathematics score, chemistry score, created date, yeah, or this one, yeah. So that's what we'll be creating in this section. So the first lab is, to install the Beaver. I believe most of us know Chocolatey, right? It's like a package manager for Windows. It makes your work easier. So if you have Chocolatey installed in your system and configured, you just need to run this command: choco install the Beaver, and it will set up the Beaver database engine for you, right? So I won't run this here because I already have it in my system, so I won't run this, but you can try it out on your own free time. Yeah, so the next point is, creating a table. So we'll run this command to create a table. I'll quickly go to my dbeaver, right? And I've already copied out this query so that I can, fasting, be fast, right? So the first one is, setting up your database. This is your dbeaver interface, a very, very nice, database engine. You can try it out. It gives you a lot of, database options, right? So I won't go on how to set it up. It's not like the scope of this sorry, this talk, right? So the first part is to create this table called scoreboard, and the ID is serial, primary key, chemistry score. So I'll quickly run this, to create this table, right? And we have a table created, right? Let us go to the next slide and see the next thing we have to do. So we are done with creating this table. You just to set the stone, right, so that we can start. Now the next part is to populate this table. So this script is just like populate the table with test data, and it's going to populate with 10,000 records, right? You can do 12,000, you can do any amount you want. It's just a script to populate, to auto populate, right? So I'll run this, and it's populated. Let me fetch it to see what to have. So we have, so many record up to 10,000. Yeah, you can try it out, after this time. Yeah, so now we are done with, setting up our development environment. Not really, but, setting up our DB, right? So the next part is, we going into efficient query. How can we do that? And, yeah, so writing efficient query. So what is efficient query all about? What is efficient query all about? For those that you solve the essay, you can know that, okay, there is the brute force approach, that is the better solution, that is the much optimal solution, right? So that is similar thing with with writing SQL. There is efficient queries, and we'll start with the one that we all know, using the where clause. This one may look so obvious that you might say, who is going to do this? But I've done it before, right? That is why I have to put it here first. So the where clause, a simple but powerful tips: always filter early with the where clause. Avoid loading the entire table into memory and filtering in the code. Bases are more optimized for filtering. In the time past, right, I've actually written a query that fetches the entire record, and then I'll use the array.stream, the .stream, then .filter to filter my record and get what I want, right? And that is a very, very bad practice. Can you all hear me? Are we together?
Very well, very well. You are coming out.
All
Yeah,
right,
we are
thank you.
together.
All right, thank you. Thank you. So that is a very, very bad practice, right? So never, I will say this one is even never, right? Never try this. You can try it on your personal development, but on a production level, something that people will use, never try to fetch all the thing, then start using your normal code filtering. So always use the where clause, right? So let's just quickly do that. For example, now instead of running this, to like fetch everything, if I'm actually working, right, instead of running this to fetch everything, for example, I want to fetch a user with this email, right? So instead of running this to fetch everything and then using the array.filter, and it's better, I use the where clause and passing the email, where email equals to what, student one. And if I run this, it will automatically, it will like quickly, give me, it will filter it down and give me what I want. So the database is more optimized for filtering. So don't do the work of the database. That's just it. Allow it to do its work, right? Now the next point is DTO projection. So sorry I didn't show the Java code for DTO projection, but I believe we may have some knowledge on DTO projection, right? But I will try to explain it with regards to SQL, right? So that I don't have to show many screens. Yeah, so one good way, sorry, it should be another good way to write efficient query is DTO projection, right? Which means, selecting only the columns you need. This ensures that this ensures less data transfer and better memory usage. For example, if you only need email and student status, instead of fetching everything, right? Just cherry pick, just pick what you need. I need email, I need the student status, you know, from the scoreboard where the email is this, right? So don't fetch the entire column, you know, when you only need the email and the student status. So it is self-explanatory, so I don't have to like go to the DB to like run this for us, right? So don't do select all when you need just maybe 2 or 3 things. So you can use your query projection, you know, on Spring Boot, you use the select new, then the package, complete package name, package, you know, directory, then, you know, the class, and you just, you know, select just what you need, right? So which is similar to something here. So just select what you need and don't select the entire column, because now if you select the entire column, you know, Hibernate have to, you know, hydrate that Java object. It has to hydrate that entity, right? And that entity may have like multiple joins. So you can see that performance is already degrading, right? So, but if you just go and you just pick what you need, it doesn't have to, you know, start hydrating your entity. It will just, you know, pick what you need and performance is tripled. Like, try this if you don't use it, but I believe who all do it. You know, there's no one that does this, but you know, it is easy to do this, because when you do your normal Spring JPA find by ID, you know, it is actually doing this because it will select everything about that user, right? So it is easier to, you know, to do this, and you mix up the entire system. While it may work in smaller hours, but as your system grow, it becomes, you know, terrible, right? So make a DTO. What do you need? What do you need? Right? I need email, I need ID, I need status. Just pick them from DB and go ahead. All right. So let's not overemphasize on that. The next part, which is very, very important, is indexing, right? So indexing makes our life easy. Yeah, in a great way, though it's like a two-edged sword, right? So it makes query efficient by serving as a search shortcut for your database, right? So instead of running a full table scan, which is your sequential scan, it uses the index to jump straight to their record and what, you know, retrieve it. So it leads to faster response time. You know, like how you have your book. For example, you bought The Richest Man in Babylon. The first page is like the index, right? If you want to maybe read about the law of money inside The Richest Man in Babylon, you just, you know, go to the index, it will tell you the page number. You boom, you go straight to that page number and you read it. So you don't have to start reading from page to page before you know, learn that the law of money. So that is how the indexing works. So we'll just quickly, you know, look into our, you know, lab on how to create index. So I've already prepared this query so that, you know, it will be fast, very, very fast for us, right? So you know, to create your index, you just need to run a query, or like query or command, right? Create index, you know, the index name, then on the table you want, and the column name. So let us say I want to create index on the email, right? Email column. I'll just run this and I'll run this and I've already created index, right? Good. I have a query here to just check the available indexes that I have, right? But sorry, before I create this index, I need to show you something. Let me delete off that index. Let me delete off that index so that I'll just quickly show you something. So before I create this index, let us see what performance looks like with that index, right? Let us see what performance looks like with that index. So if I run this explain, analyze, right? It's just like a query plan, right? If I run it, you see that we have, you know, sequence scan. That means that we have a complete table scan for every select you do, you know, finding by email. The database engine will need to run through your entire record. Just imagine you have 10 million records. It has to run through it, right? So that shows that you're having sequence scan, right? Now, how does index, you know, make this better? So if I now go ahead and I create my index on this, right? Let me create my index on this. And then I run this, you know, query plan again. You can see that, you know, it's now using index scan, and the execution time is quite reduced, from the 7 point something that it was before. So this is how indexing makes your query look up very, very fast, right? But like I said earlier, indexing is like a two-edged sword. So you should only index, your frequently used columns, right? And two, for me, I would suggest that you don't index too early. Don't index too early. Index when your table is growing big, right? That's when you really need it, because index also has a way, of bringing down your right time, right? It affects it with more this thing, with more index you create. But we'll see that as time goes. So indexing strategies, right? So just like every other thing in life, indexing requires. Can you hear me? Can you hear me, please, everyone? Hello, are we together?
Very well, very well. You are coming out.
All right. All right. Thank you very much. Thank you. So just like every other endeavor in life, we apply strategies, right? So indexing requires the right strategy to deliver real performance benefits. Yeah. So without it, indexing can easily become an overhead with little to no gain. So in this discussion, I'll be focusing on three strategies for index. Though there are many strategies for indexing, but I'll be focused on just three so that I can round up quickly. Single column indexing, composite indexing, and functional indexing. So I believe these ones are the ones that will get used on a daily basis. We may not really use filtered indexing or partial indexing. We may not really use them on a daily basis, but these three are like what we use on a daily basis. So that is why let's look into them. So single column indexing, like the first one that we created, the first index we created, you can see we created it on just one column. For example, create index, this IDS email on, scoreboard email. You can see you are creating on just one column, right? It is your single column index, right? This works fine. It's really works fine. But when you start having you have maybe two or more filter criteria that you frequently use in your where clause, right? You can see that using single column indexing, for example, okay, I'll still get to that. Okay, let me not run too fast. Yeah, so this works fine if you are filtering by maybe just one hot column each time, right? For example, I'm always filtering by email and nothing else, right? This works very fine, right? Now it works until it's not recommended anymore. I'm not saying you shouldn't use, but I say it works until a point where you shouldn't use it. There's a point you should use a different strategy. So let us see that point. Yeah, that is your composite indexing strategy. So for example, I will just go to the database directly so that I can quickly. So for example, now I have this query that selects by email and by student status. Let us say this is a frequent query, right? I'm always selecting by email, and sometimes I also select by student status, right? You can see that there's an extra condition here, right? Good. So instead of indexing email and student status differently, it will make a lot of sense to index them both together, right? Good. So now I can create an index here on both of them. So if I create an index on both of them, yeah, but yeah, I can create an index on both of them. And if I run this query again to view my list of indexes, you can see that I have three indexes, right? One is from the primary key, which is the default, and the other one is from the index email and index email status. But now let us look into this critically. You have index email, I have index email status. You have two indexes. But this index, this composite index I just created on two columns. How it works is that if I'm filtering by email, it should work. And if I'm also filtering by email and student status, it should also work, right? So that means that I don't even need this first one I created. So that means that I should go ahead and drop it. I can drop this index here, quickly drop. I can, quickly, drop it, right? And if I run this query now, let me show you that it works. If I run and explain, analyze, on this, you can see that, let me run quickly. You can see that we are still using index scan, right? Index scan is still being used when we filter by the two of those columns. And if I also filter by just one email, let us see if the index scanning also applies. You can also see that it still uses index scanning, right? So that means that your composite scan, your composite index, sorry, should be preferred, over your single column index, if you have more than one criteria. And mind you, like how you index it, email and student status, that is how it applies. So it applies when you just filter by only email and when you filter by both, right? So there's no point, now having two of them. Yeah. So let's quickly go over, to the functional indexing. Sorry, I rushed over this. Composite indexing is indexing two or more columns, right? Instead of having them separately. Now let's go into the functional indexing. Yeah, so this one solves a lot of problems, like critical problems, right? Now, for example, you have a table, right? A very large table, right? And the email, the email column, that is emails, are not, uniformly cased. Some are having uppercase, some are having lowercase, and you don't have the option to normalize them. You cannot, bring this whole email to like same casing, right? Like it is a very large table and you don't have the permission or the option to normalize them. So, you want to apply indexing, right? So instead of just creating a single column index on email and hoping that user will supply the correct cases, right? It is better to create functional index on email and convert user input to lowercase before filtering. Yeah. So I will show you a code example. Yeah. So for example, now, like I told you earlier, your email is not uniformly cased, right? So if you create like a normal, like your traditional indexing on email alone, right? Now let us just see this query so that I don't, speak too much on this. So let's see this query. So for example, now, you know that I index the email, right? I index the email. So if I do an explain analyze on this, let me just quickly copy the explain analyze so that I don't spend too much time writing. So if I quickly do an explain analyze here, you can see that here I'm passing a function, right? This lower function. So if I do, this stuff here, you can see that it is using a sequence scan, even though this email is already indexed, right? So if you have this situation, it is better you do a functional indexing. And how do you do a functional indexing? Simple. Same way you do your normal traditional indexing, simply come here, pass it as lower, since you want to use lower, right? Pass it as lower, and you can, create your index on this, right? Just run create index, same thing, but use the lower function. So if I do this and I come back and I run this, let's see what we get. Can see that we'll get like a bitmap index scan, which is not so optimized like your normal index scan, but it is better than your sequence scan, right? There are ways, you can make it better, but we'll not go into that, right? So we have seen the problem that functional indexing solves, and not just lower and upper, even date. If you want to use date function, if you want to, once you want to do a function, right, and you want like a faster read, indexing gives you this faster read, right? I want a faster read. It's better I use functional indexing, right? So it solves your problem big time. Yeah, so let us quickly move into the avoiding performance killers. Yeah, it's going to be a quick one. So we have discussed how to optimize queries. In this session, we'll quickly look into few SQL performance killers and how to avoid them. It is important to know that creating an index does not guarantee that it will be used. Like we need to pick this and note it down. Like for the fact that you created an index doesn't mean that the database engine is going to use it. The optimizer can always check, okay, is it better I use a sequential scan or is it better I use your index scan? And the purpose of creating an index is for it to be used, right? So if you create an index and it's not being used, that means that there is something wrong with your query, even if it's running, but it's not good enough, and the optimizer have seen that your query is not good enough, so it will go back to sequential scan or something less optimized, right? So we need to avoid that, right? So here we explore, how to increase the chances of the database engine actually being using our indexes. Please, can you all hear me? Hello?
Very well, very well.
Yeah, we can.
All right, thank you very much. So now let's quickly run through this. Yeah, so this one is very, very important, like very, very important. We need to, even if we don't gain anything from this class, for this lesson, just need to get this. Creating index on a less cardinal column. For example, you have, a student table, right? And there is ID, first name, last name, gender. I can see that gender, for example, in Nigeria here, right, we have basically two genders, male and female. So there's a possibility that everybody in your class will be male. Like I've been in a class where it is just 90% males and 10% female, right? So you can see that gender is less cardinal, right? So if you create an index on a less cardinal column, you won't get the benefit of indexing, right? Because the optimizer will see that most of the records are falling into this category. So there's no point of using index. It will do a full table scan for you. And also avoid creating indexing on booleans, right? Because it is true or false. There's no that thing that boolean can be true or false. So all the columns may end up being true or being false, So avoid creating index on a less cardinal columns, But if you must use, for example, your gender, if you must index your gender column, for example, now combine it with something that has a higher cardinality. For example, first name may have a higher cardinality, so you just need to create a composite index, right? Combine it so it increases the chance of that index being used. Yeah, the or operator, I believe we all know this. If you have to, for example, you have select all from users where email equals to this or phone number equals to this, and you have indexed your email and phone number. So using the or operator, sometimes the DB engine may not efficiently use the index. So the solution is actually most times is to use the union operator. So because of time, I will not be demoing this because I'm almost out of time. So is to use the union operator. So this ensures that this part of the query is going to run on its own using the index you created, and this one will run on its own using the index you created, and it is way more optimized. So you can use the union, I can use the union or, but the union or is going to give you duplicates, if maybe there is duplicate, but the union will ensure that you don't have a duplicate. So it all comes down to what you want. Then the last one is, using functions on a non-functional index. Yeah, for example, you created index on email without lower or upper, right? And you end up using select all from users where lower email equals to this. So automatically the database optimizer will not use that index because what you created is a normal traditional index, not a functional index. Can you hear me? Hello?
Very
Hello?
well, very well, very well. You are coming out.
Okay, thank you very much. So if you must use functions in your where clause, check your indexing, check what you have, create a functional index, and that is it. Create a functional index if you must use a functional indexing, right? Then don't interchange them. Yeah, so before I go to the last slide for always, indexing is not a one-off something. It is a simple app that can make your system very, very fast, that, right? But it's not a one-time of something. You just index and you go. You continuously re-index, you continuously check your query pattern. What has changed over time? What am I currently most often used? You re-index, you delete the old ones, and you bring in new ones. That is how you make your system better. So it's not like a one-off something you get. So don't just index, once and you go, because once you index once and you leave it, you have many people working on that system. They may change the queries, update the queries, and the filtering criteria may have changed. So you have to always reevaluate, profile your queries, then go back and re-index. Delete the old ones so that you don't have many indexes. Always avoid too many indexes because it will affect the read. Yeah, so database query optimization is a vast topic, and we
Okay, apologies everyone. Good evening. I think he's battling with his network. So let's just bear with him. We all know how Nigerian network is really hectic. In the meantime, please let's keep our eyes on the chat. A new link will be dropped for the question and answering section. We'll be running out of time in the next 10 minutes, so we can join that link while we are waiting for him. Thank you. It will be dropping shortly.
can you hear me? Hello?
Yeah, very well. You are coming out now.
Welcome.
Yeah,
Yeah,
welcome.
sorry, I lost my network. Sorry. Let me reshare my screen, please, so that we'll just quickly round up.
Okay, yeah, but we quickly shared because we are currently running out of time. I believe we have
Okay.
like 11 minutes. So a new link was dropped in the chat. I will drop it again now. So we could just join that new link. So you can handle the question and answering
Okay.
section as well.
Okay,
Yeah.
thank you very
Thank
much. All
you.
right. Yeah.
Please, if you're still here, please let's join the new link. Let's all join it, please, so we
Can you
can
hear
kickstart.
me? Sorry, that link, I've not seen the link, please.
Okay, let me drop it again in this
Okay,
chat on this
okay,
call here.
okay,
Yeah,
okay,
yeah,
okay. Okay, so it's been here all this while. So I've been looking
yeah.
at
Sorry about that.
for it on the group chat here.
So please, guys, let's join. Other persons are there. Let's just join and then we kickstart from there. Apology for